Have you ever just stopped and thought about how connected everything is? Seriously, the time of day connects to where the sun is in the sky. The price of your coffee connects to its size. These connections are absolutely everywhere. And the cool thing is, math gives us a super precise language to talk about all of them. So let's jump in and build our understanding of this language, one piece at a time. I mean, think about it for a second. Generally speaking, as a person gets taller, their shoe size goes up too, right? It's a perfect real-world example of a relationship between two different things. Now, it's not a perfect one-to-one rule for everybody, of course, but you can't deny there's a connection there. And that's exactly what we're going to do. We're going to treat this like a construction project. We'll start with the absolute foundation and add each new piece one by one until we've built a solid structure for understanding these mathematical connections, or as we're about to call them, relations. Okay, so our very first building block is something you're probably already an expert at, even if you don't realize it: spotting patterns. Because really, when you get right down to it, relationships are just patterns in disguise. Check this out. It's a simple three-step process. First, you just look. What's actually changing each time? Well, it looks like we're just adding one block, right? So step 2, we put it into words. You start with one block, and then you add one more for each new step. And finally, boom, we can write a rule, like the number of blocks is equal to the step number. Just like that, we took a picture and turned it into a math rule. That's an awesome start, but a rule by itself is kind of floating in space. We need a place to put it. We need a map, somewhere we can actually plot our points and see the connection come to life. And here it is, the Cartesian coordinate system. I'm sure you've seen this grid before. It's made of two number lines that cross each other. The big idea here, the most important thing to remember, is that this grid gives every single point its own unique address. And you can think of it just like a street address. The x-axis tells you how far to go left or right. That's your horizontal address. Then the y-axis tells you how far to go up or down, your vertical address. Put them together, and that x, y pair takes you to one and only one exact spot. So let's put it all together. We can take our block pattern from before and give each step an address. Step 1, which had one block, gets the address 1, 1. Step 2, with its two blocks, lives at 2, 2. You see where this is going? Our pattern isn't just an idea anymore, it's a set of actual points we can see on our map. All right, we've got our building blocks ready. We know how to spot a pattern, and we have a map to draw it on. So now it's time to finally give this thing an official name and define what a relation actually is in math. And believe me, once you start looking, you'll see relations everywhere. Anytime you pair up two pieces of info, you've got a relation. A person and their birthday, that's a relation. A city and its country, a relation. An item at the store and its price, you guessed it, it's a relation. And that's the whole secret. That's the big definition. In math, a relation is just any collection, any set of these ordered pairs. It's a bunch of points, a list of connections. Seriously, that's it. It's that straightforward. Okay, but with any relation, we usually want to know its limits. Where does it exist on our map? What are its boundaries? We need a way to talk about that precisely. So let's use this little graph right here as our example. We've got just 5 points plotted. For right now, this set of 5 pairs is our entire relation. So let's take a closer look at their addresses. First up, just focus on the horizontal part. Forget about up and down for a minute. Just look left and right. Which x values actually have a point sitting on them? Go ahead, take a second and just list them in your head. That list of all the possible x values, it has a special name, the domain. So for our graph here, if you look at each point and drop a line down to the x-axis, you'll hit -4, -2, 0, 1, and 3. That's it. That's our domain. It's the complete list of all the inputs our relation uses. Perfect. Now let's do the exact same thing, but for the vertical positions. Looking at those same 5 points, what are all the y values that we're using? And that list is called the range. It's the set of all the outputs or all the vertical positions in our relation. So if we trace each point over to the y-axis, we land on -3, -1, 1, and 2. Now you might notice that 2 different points share the y value of 1, but we only list it once. The range is just the set of all the unique outputs. So here's the big takeaway. The domain and range basically draw a frame around our relation. They tell us exactly how far left and right and up and down it goes. Let's go back to the shoe size and height idea. The domain would be all the different shoe sizes we recorded, and the range would be all the different heights. It tells us the boundaries of our data, the smallest shoe size, the tallest person. It gives our connection a precise footprint on the map. So today, we built up this really powerful idea that a relation isn't just any set of connections. But what happens if we add one more little rule? What if we decide that for every single input, every x value, there can only be one possible output? Well, that creates a special kind of relation that's even more powerful. And that is a story for another time.